Welcome back to lesson 6 of the Java tutorial series, and today we are going to talk about stacks and enumerations. So these two are semi-related, but not really. But I wanted to get onto enumerations because next lesson we're going to talk about classes and objects. So classes and objects, again, are pretty much the core of Java. So we want to build up to that so that we can have a solid understanding of classes and objects. And now what you want to ask is, why do we want to talk about stacks? Now stacks are, and queues and decks, they're like all in the same category, but the reason why I want to talk about stacks is because how counterintuitive it is. It's not hard, it's just sometimes if you forget how they work, you can break everything in your code. So enough talking in the intro, let's just get on to Eclipse. So we're in Eclipse now, we have a blank canvas. Last time we talked about hash maps and array lists, and those are pretty intuitive. You can add stuff, but stacks have a different sort of property, which is that they're like a stack of plates. So that's what I suggest you to think about, which is the stacks are a stack of plates. If you want to add some plates, I have some plates in here. So we have plate 1, so we want to put that at the bottom, 2, 3, and 4. When we try to access plate 1, what do we have to do? We have to pull out 4 first, and then 3, and then 2, and then 1. So that is how a stack works. So let's define our stacks. But first of all, stacks aren't a primitive, function. They have to be imported. But luckily, Java's runtime has a collection of good imports. So we just do java.util.stacks. So just like that, the friendly developers at Oracle, actually let me change this to stack, have created a bunch of libraries for us in the utility section so that we can use them. So let us define a stack. So to do that, same thing as array lists and hash maps. We want to do stack, and then we want to talk about what we want to put in here. So let's just put a string. So a string stack. So stack, and let's us do some let's do some cars here. So let's do cars again, and then let's follow through with our constructor, and boom, Eclipse automatically highlights. I don't know what editor you're on, but this should work like so. And now we can add some elements in it. So to do that, we want to do cars.push. So let us push some cars in here. So let's push Volvo. Volvo. Okay. Let us push Honda. So Honda in here. And let us push Ford. So we have 3 cars. And you know what? Let's, for the heck of it, let's push, let's push BMW too. So we have 4 cars in our stack, and if we run this, we can see that it'll print pretty much everything in the stack. So let's do cars.toString. So unlike a array list, you want to add toString or else it wouldn't print. So let's run it. And as you can see, it prints the order we added them. Seems like an array list so far. But the keyword is so far, because you can't really remove stuff. In array list you do, dot remove and stuff. But then no, there's none of that in stacks. You do a special function called dot pop. So we do cars dot pop. And yeah, it takes nothing. So you can't really pop a parameter. It just pops the default last value. So that's where it gets counterintuitive. Remember, it does not pop Volvo. Because if it does pop Volvo, then it will become a queue. So queue is pretty easy to understand. Like a line, Volvo comes in. When you pop it, Volvo goes out. But stacks is different. It pops the last person who comes in. Or in this case, BMW. So when we run it now, BMW will be gone, but Volvo will be still here. So take a look at that. Now if we pop it again, Ford will be gone. So let's just do it. When we run, Volvo and Honda's there. and forward is gone. So just like that, that is how popping works. You can see, kind of not hard because again, I recommend you to visualize, it as a stack of plates because you can't really take down the bottom one without taking the top one first because then everything will collapse. So that's stacks. Now we can actually peek at a certain element. So we want to do peek, and this will return the top value. So if you're thinking about stack here, you can only peek at the top value because the bottom values are hidden. So when I run it, BMW appears. Now if we do cars.pop, guess what will appear? That's right, Ford will appear. So when we run it, and boom, Ford will appear because we removed BMW from the stack. Boom, BMW's gone, and now Ford is here. So that is pretty much how they work. One last thing about stacks is that you can actually search for an element. So all we want to do is we do search, and then let's search for Honda. So Honda will be indexed at 1. So they're still indexed at the same spot, but if you see here, this is different indexing. Again, I'm cautioning you. This isn't a queue. And Honda, the reason why it prints 3 is because BMW is the first one. So if you're counting from the top to the bottom, you want to count the top plate, which is BMW, and then the Ford, and you finally arrive at Honda, which is position 3. So when you're using this search command, don't, be cautious about that because if you don't, you might accidentally wind up in a different array and stuff. So just be cautious that. If we do BMW, as you can see, it will print out 1. But if you counterintuitively thought about it, you would think, oh well, isn't that just like a queue? But nope, it's a stack, which is the last in is the first out. So this is very important. Let me just add it up here. So last in, first out. So remember that. So whatever you added in last, it will be indexed at 1. So yeah, one more thing about search. Let's add some random card that doesn't exist, like this, a random string. So what would this print out? It will just print out -1. So if you're using that for some algorithms, that would be useful because you can check if like something equals -1, if blah 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 equals -1, then do something if it doesn't exist. So that's how it works. And let's remove this. Now we're going to talk about enumerations. So enumerations are very, very special because they are user-defined pretty much classes, except without classes, you can't really change them. So let's see how we can define them. So enumeration, we just type enum, and we want to define something that will remain true forever. So we can't really define, we can't define like usernames or account balance because that would change. But one thing wouldn't change, for example, weekdays. It'll always be Monday, Tuesday. Oh, right. Also, the convention is that you want to name it all caps just so that you can distinguish it between a constant and a variable. So variable can change. Constants can't change. If you remember in science class, constants remain the same. So these are constants, and these are variables. So we'll talk about constants later. There, in the probably next or probably following episode. But right now we're talking about enums here, and this is what's going on. So we have this, and to define an enum, we want to type like so. We want to do weekdays, Friday equals weekdays dot. So yeah, as you can see, kind of looks like the stack constructor. We're constructing our own data type here, but not really. It's just an enumerator. So when we run this, let us print out Friday. It's gonna have you guess what it prints out. but obviously you will probably know it prints out Friday. So FRI. So because that's the enum. Same thing with weekends. We can add more enumerators. So weekends. That would just be Saturday and Sunday. We can also do this for country codes. So country codes. So we can do that. We can do United States, China, United Kingdom, France, Russia, so on. But all of this will work. And you can see country codes, weekends, and weekdays all have one property. They don't change. Unless something happens down here, weekends and weekdays don't really change forever. So you can use your code, reuse the enums without having to worry about it being a constant. So let's remove this, and I'll show you how you can loop through it. So remember our friend here, our for each loop. So to loop through every single every single enum, we want to do weekdays. Actually, let's do weekends first. So we want to do weekends, and you want to define arbitrary variable. So let's just do underscore, or we can do I. And then our Google colon here, and then we want to do weekend dot value. So remember, actually values. So remember this, because this is important. It's getting all the values, and we will just copy this. Once it prints I, it should print Saturday and Sunday. Oh yeah, Friday, Saturday, Sunday, because I forgot to comment this out, just to make sure no confusion. Saturday and Sundays. Yep. Just like that. Now, just prove that it actually works for other things too. We can change it to weekdays. Naturally, we have to change this to weekdays too. But now, this will print every single thing in here. Again, the power of for each loop. The more you learn. So, obviously, the comment Friday, but starting from here, ignoring this line, you have Monday, Tuesday, Wednesday, Thursday, and Friday. So that is the power for each loop. We're going to be using it pretty much for the rest of the series when dealing with stuff like this. You can do the other way around, but I don't really suggest it. But that is pretty much it for enums. Very good little introduction to classes. Again, not fully classes because you can't really modify them, and you can't really create objects with them. So this is constant. So that is pretty much it for today's lesson. We talked about stacks. Hopefully you'll get a better understanding on how stacks work and how enums work, which again, foreshadowing next class. We're going to talk about classes and objects. And you'll see finally what all of this means, all class and all static void, all of that will make sense in the next class. But if you enjoyed this video, please leave a like and subscribe. I'll see you in the next one. Peace out.